Hello, and welcome to 2.2. This is characteristics of quadratic functions. Today we're going to look at pieces of graphing quadratics, things like vertex and y-intercept, and looking at different forms of the quadratic like standard form as well as intercept form. So this really is just all about graphing. In Algebra 1, you don't really graph too much with quadratics or really explore different types of equations with quadratics. And so Algebra 2, we're going to look at quadratics that come in different forms and also how to graph those particular functions. So the first thing, we'll talk about axis of symmetry later. The first thing you want to understand is that there are multiple forms of quadratics. One, which you're probably very familiar with, is standard form. This is the form that in Algebra 1 you are most likely to see. Some number times x squared plus some number times x plus some number as a constant. That is called standard form. Ax squared plus bx plus c. Now, all these different forms are going to give us some sort of benefit or some sort of information right off the bat. And we'll talk about those in a second. The other thing that we need to understand is what is a minimum value versus a maximum value. Well, minimum and maximum are both types of vertices or vertex. These are both types of vertex. Where you get a minimum value is if your parabola is a normal shaped parabola that goes down and back up, the vertex would be at the bottom. It's the lowest point. If your parabola is upside down, like this, then the vertex becomes a maximum point. And those are important to note when we actually are doing these in the graphing calculator, because you need to tell the calculator whether to find the minimum or maximum. The other type of form we're going to go over today of quadratics is going to be intercept form, which is y equals a and then x minus p, parentheses, x minus q. So I mentioned that each form, there's actually a third form called vertex form, but we're going to address that next class. But I told you that each form always gives you something. The intercept form, the p and the q here end up being your x-intercepts. So if you want to add in here that p and, I should not put plus, p and q are x-intercepts. And that is what is unique about intercept form. Intercept form essentially gives you the x-intercepts because it's p and q. The only thing you have to be careful with is this minus sign in here. So whatever number we do see here, because the formula has a minus sign in it, that makes it become opposite of what it is. So when we're dealing with real problems, the x-intercepts will actually be opposite of this due to these negatives. Standard form, the unique thing about standard form that it gives us is that c equals your y-intercept. So whether it's in standard form, the c here will always be your y-intercept. Intercept form, the p and the q will be your x-intercepts. There is also another form called vertex form, which coincidentally gives you your vertex, but again, we'll talk about those another lesson. So here's the first one. This is standard form here. This is standard form, ax squared plus bx plus c. And so when asked to graph a parabola or a quadratic function in standard form, the first thing you're going to want to do is find the vertex. And so the way that we find the vertex is actually down here. And it is this x equals negative b over 2a. This b over 2a, and what the heck are a's and b's? Well, these are the coefficients that are in front of these variables a and b. So when you're going to find the vertex, you're going to take whatever b is and do negative b, and then put that over 2 times your a. And what that does is it gives you the x value of the vertex. So if you remember, vertex is a coordinate. It's a point. It's a point on a graph. So that point is going to be x comma y. So when this negative b over 2a essentially gives you your x, you then have to figure out what your y is. And the way that you do that is by taking the x value that you get here and plugging it back into the system for x. And once you plug it in for x, the output that you get, or your f of x, will be your y. And that ends up being your vertex. And then we'll go from there. So let's look at what that looks like. So we're going to scroll all the way down here, and we're going to start off, we're going to kind of jump and bounce around here. But this is a problem here where the problem is in standard form. And so we are going to need to be able to find the vertex. And remember, vertex, to find the vertex, the first thing we start off with is the x equals negative b over 2a. Now remember that this is your a, this is your b, and this is your c. So negative b, in this case our b is already negative, so negative b simply will just make it positive 3 over 2 times a. Well, 2 times 3 over 2 is 3, and so we get this value of x being 1. So when I go to do my vertex, I know that the x-coordinate is 1. I don't know what the y-coordinate is yet, but I do know that the x-coordinate is 1. So in order to figure out the y-coordinate, I can take the x-coordinate, plug it back into the system, and whatever I get as my output here will be my y. So what I'm going to do is I'm going to plug this in. 1 will go right here, and 1 will go right there. Just remember your order of operations here. I do need to square it before I can multiply by the 3 over 2. So 1 squared is 1. 1 times 3 over 2. I'm gonna change this to a decimal. 3 over 2 is 1.5. So 1 squared is 1. 1 times 1.5 is 1.5. And then minus 3 times 1 is 3. And then minus 1. And so that is plugging 1 in for x, and now I figure out the output. 1.5 minus 3 minus 1 is negative 2.5. And so this vertex will be at 1, negative 2.5. So I can plot that. I can go, okay, 1, negative 2.5, that's about right there. And that will be my vertex. Another thing that we learn with parabolas is parabolas are symmetrical. Parabolas, like circles or squares or rectangles, are symmetrical shapes. So what that means, that's a very important piece of information, is that we have this sort of what we call the axis of symmetry, but it's this imaginary line. Think about like if you're folding a paper or something like that. It's this imaginary line that acts as symmetry for us. And that axis of symmetry, which I abbreviate as A of S, axis of symmetry will simply just be x equals whatever the x is in your vertex. This will always match. X is 1 in the vertex, so my axis of symmetry is just x equals 1. So what you should see is that this should match this. Now, how do we get the other points? Because in order to graph a parabola, we need at least 3 points. Not like lines where you need 2. Because of the parabola shape, we actually need 3, including the vertex. So here's where that other piece of information comes from. If you remember from above, we told you that quadratic functions that are in standard form will always give you the y-intercept, and that y-intercept is always c. So I know that the y-intercept based on this equation is negative 1. So I can go over here and go, okay, -1, there's my y-intercept. Now here's where the symmetry comes in and makes this amazing, or that makes this awesome. Because I have symmetry in my graph, I know that this point that's on the left-hand side should have a mirror image of that point on the right-hand side. So I can graph my second point, or third point, sorry, there. And then I'm ready to graph. Just like that. So that's graphing in standard form. So I'm gonna do another one in standard form. I apologize, but I kind of changed the trajectory of kind of what I wanted to do in this unit. So the notes aren't exactly the way I wanted them to be. So I'm gonna make a few changes here. I'm gonna change number 1 into a different type of problem, and we'll do this one together, similar to the one we just did. So I'm gonna change this to -x squared minus 2x plus 2. And so what we're going to do is we're going to do exactly the same process. I'm going to go a little quicker this time, but it's going to be the same process. So we're going to, first, again, we are going to find the vertex. Just like we did over here, the x part of the vertex is the x equals opposite of b over 2a. So I'm going to do that over here. X equals opposite of b over 2a. In this case, the opposite of b, since b is already negative, it's -2. It'll be +2 over 2 times a. A is right here. It's -1. So 2 times -1 is -2. 2 over -2 is -1. And so the vertex, the x value at least, will be -1. I don't know the y value yet, but we'll get there. So now to find the y value, I need to take this x value here and plug it into the x's in my equation. So I'm going to do that, negative and then -1 squared minus 2 times -1 plus 2. Careful here, make sure you are doing your order of operations first. I do need to square this first. -1 squared is 1. Then the negative gets tacked on, so it's back to -1. -2 times -1 is +2, and +2. -1 plus 2 is 3. So now I have my vertex, -1, 3. And so there it is, -1, 3, there's my vertex. And so again, I have this imaginary axis of symmetry that's going to help us out here in a little bit. This axis of symmetry, or A of S, is just x equals whatever the x is in your vertex, which is -1. Again, when the graph is in standard form, I know my y-intercept. Here is my y-intercept right here. It's the c. It's +2. So there is my y-intercept there. Again, parabolas are symmetrical. So this point that's here on the right will have a mirror image of the point on the left-hand side. And I have all 3 points that I need, and I can graph this. So that's graphing a parabola, or I guess a quadratic function that's in standard form. The next thing is, we're going to kind of skip back up here, is the form called intercept form. So this is intercept form, and so the unique thing about intercept form is it's going to give you your x-intercepts. The only thing that to be careful with here is this minus sign. The minus sign that's there is going to flip any signs that are there and change them to the opposite, meaning that if there was like a 5 and a 4 in there, it actually is -5 and -4, and vice versa. So we're going to go down and do a problem here that is in intercept form. So here's our intercept form right here. So right away, I don't have any formula to find vertex. Vertex formula only works when it's in standard form. So here, I'm going to start out a little different. I'm actually going to start out with my x-intercepts. Now remember that those formulas have minus signs there, so they're actually going to flip them. So my x-intercepts are actually -4 and +3. So when I do -4 here and +3 over here, those are my x-intercepts. Now what's great is that I already have 2 points. I only need a third point, and which means I only need the vertex. But here is where that magical axis of symmetry comes in. Because I know that the parabola is symmetrical, I know that the vertex will be in between these. In fact, it'll actually be in the middle of these. So knowing that there are 7 spaces between these two dots, if I cut that in half, that's 3.5. I know that the vertex will be 3.5 from either side. Now, I don't know the y value, but I do know that the x value is right there. And then right there, that x value, so vertex, is going to be what looks like negative 0.5. So I didn't even need to do any formula. By knowing the x-intercepts, I can just cut those in half and find the x value of my vertex. And then I can do exactly what I just did in the previous problems. By simply just plugging this in, I can find the y value. And so that's what I'm going to do. I'm going to plug in my negative 0.5 in for x here and then solve. So what I have is 4 times negative 0.5 plus 4 is 3.5. And negative 0.5 minus 3 is negative 3.5. And I just multiply those all. 4 times 3.5 times negative 3.5, I believe, is negative 49. So my vertex would be at negative 49. Now, obviously, that's not going to fit on this graph. It's going to be way down here. But if I could fit it on the graph, I would have all the information needed to draw this graph. And so my axis of symmetry, which I already stated, is x equals whatever the x is in my vertex, or negative 0.5. And I have everything that I need. So now, just like the previous problem, I'm going to do another one here. I'm going to just change this one right here. Again, I'm doing it a little different than I wanted to do initially when I made these notes, so sorry for all the changes. But here is another one that is in intercept form. So we're going to do 1/2 x minus 2 and x plus 4. So again, from this information that is given to me, I know that the x-intercepts are the opposite of those signs, or positive 2 and negative 4. So when I graph this, here is positive 2 and negative 4. Now, because parabolas, again, are symmetrical, I can figure out where the vertex is by simply just cutting this in half. So it looks like there is a 6 space difference between those. So half of 6 is 3. So if I just go over 3, that should be the middle right here, which turns out, I guess, to be negative 1. So my vertex will be negative 1 and something else. So to find out what the y value is, I'm going to just plug it in, that negative 1. So I have 1/2 and then negative 1 minus 2, negative 1 plus 4. So negative 1 minus 2 is negative 3. Actually, I'll just do it down here. So 1/2, negative 1 and negative 2 is negative 3. Negative 1 plus 4 is positive 3. Half of negative 3 times 3 is negative 4.5. So I know that my vertex is at negative 1 and negative 4.5. And there you go. And now I can connect these dots. And I have my graph. I also have the axis of symmetry. We don't want to forget that. Axis of symmetry is simply just x equals whatever the x is in my vertex, which turns out to be negative 1. That's it. That's all we were doing today. No word problem, no vertex form. We'll keep that for next class, and that's it. So thanks for listening.